Welcome back. In this lecture, we will discuss the fourth sorting algorithm, share sort. In the last session, we discussed insertion sort. So insertion sort, we use the key element and we may right shift the predecessors of the key elements. Okay. And share sort is a variation of insertion sort. But the step size or gap size, when compare the key element with its predecessor, it's adjustable. It says it's a step size, or so we have some step size or gap size when compare the key element with its predecessor. So that's a difference, not just always one, okay, as in the insertion sort. And the step size, and also it says adjustable. Because the step size can start at some large step size. So it's a half size of the whole list. So that's quite large step size, okay. And it's decreased by half in subsequent iterations, okay, until the step size is one. But when the step size is one, basically it's insertion sort. Okay, so that's the difference here between share sort and insertion sort. So it use some adjustable step size. And that step size starts as a half of the list and decrease by half each time. Okay. And because of this, so the algorithm involves three tiers of nested loop. Okay. The outermost loop, it iterates over the step size. So the step size starts at the half of the list size and decrement by half each time until its size is one. Okay. Then the middle loop. Middle loop is advancing the key element. So that's the middle advancing key. Okay. And it's basically like the insertion sort out loop. Okay. And the innermost loop, it's similar as insertion sort. But when you compare with the predecessor, okay, it's located at a distance defined by the current step size. So the predecessor is away current step size. Okay, and then adjust the position accordingly. So that's the general idea about share sort. So let's take a look at an example. How are we going to do that? Oh, the advantage that share sort over insertion sort, because it's a start with a larger step size, is share sort allows out of order elements quickly move closer to the final positions because of the larger step size, the gap size. Okay, so that it makes the subsequent iterations with a smaller step size more efficient. Okay, so in this way, it can reduce the number of comparison and swaps compared with the traditional insertion sort. This is especially useful for larger data set. Okay. Now let's take a look. This example, still the same list as the previous discussion. So for share sort, so the step size at the first out loop iteration, and there are three tiers of loop. Okay. So we start with the very outermost loop. Okay, so it start with the step size. Step size start at half of the size of your list. Okay, so in this case, we have 7, so the step size and set as 3. Okay, and because of this, step size 3, so the first key element, then it's step size away, so 3 away. So 87, the middle one, will be the key element. So this is the key. Okay, and then it will start at the second level loop. Second level loop is advanced key each time by 1. Okay, basically it's each iteration. Okay, okay, so we start at 87, and when you do the comparison, so the most inner loop, so innermost loop. So what it does is compare and right shift if there is necessary for right shift. Okay, so when we compare the predecessor determined by the step size. Okay, so this is different. Okay, so it's a 69, is it, step size? So 3 away. Okay, 69, you compare with it. And to see if it is larger. If it is not larger, is it, then we don't have that temp and location. In this case, there is no record. Then you advance the key to the next one. Okay, so this time 50. Then you compare with the step size away. So it's a 35. So this one is also smaller, so there is no need. Okay, and then you advance. So now it's 58. Then you compare with the step size away. Okay, so we can clearly see there is no need to do the right shift. Okay, and then you compare with the last one, 79, you advance the key. And then you compare with the step away, so it's 87 in this case. And this key is less than, okay, so you still keep track of key, it's 79, is it? And its location index is sub 6. Okay, and you compare with the predecessor, it's 87. And it is less than this, so then we do need to right shift step size. Okay, so 87 move to 79. Okay, and then location decrement by the step size. So minus size, is it? So location updated to 3. Well, now you need to move this 79, then to 89. Okay, or 87. So 79 is moved. So now it's 69, 35, 18, 79, 50, 58, and 87. Okay, so after the first outermost loop, so we move you can see the largest item, is it moved closer to its location. Okay, so from in this specific example. So that's the advantage of share loop, share sort. It's move the larger item close to the position that is supposed to be. So it does reflect this. So that's the end of the first iteration step size at 3, is it? And then the next iteration, you reduce the step size by half. Okay, so it's 1. Okay, we just take the integer part, so the step size, then update it to 1. Okay, and with step size updated to 1, updated 1, is it? Then same thing. And we first need to set up the key, okay? So then this time, this is the key, okay? And the step size 1. So basically, we can see this is the insertion sort in this case, okay? But if you have larger size of the data set, then you can clearly see that next time the step size reduce a little bit, so it's going to move the item more close to their correct positions. Okay, so because this already, in this case, especially this already reduced the case to insertion sort. So basically, we can repeat the same steps as we discussed in the previous lecture. So that's the main idea about share sort. Okay, so share sort, the variation is the change of the step size. And because of the change of the step size, when you do predecessor comparison, then the predecessor also defined as a step size away. And also, you need to, when you do the swap with the key element of the predecessor, and not just a predecessor, when you do the comparison, step size away, okay, and then if there is any predecessor that's so that you do need to swap, then we also keep track of the index that you're supposed to do the backward. It's also step size away. Okay, so a similar concept. Okay. So that's the whole idea about share sort. So let's stop here, and we will discuss the next sorting algorithm in the next lecture.